Good morning to all. One and all who are gathering here. I introduce Mr. Sarika, Department of Faculty of Computer Applications, Dr.M.G.R in Education and Research Institute, Maduravoyal, Chennai, to compare the entire session.
A very pleasant morning to all the techies who are here to enhance your skill. We don't grow when things are easy. We grow when we face challenges. Train your mind to see good in every situation. Radiate the positivity. With that note, behalf of Dr.M.G.R Education and Research Institute, Chennai, I'm Sarika Nagaraja, Assistant Professor. Extend a warm welcome to all the guests extended all over the world. Before starting the session, let's say a small AV of our esteemed university.
Yes, 198074.
We'll see the AV of our university.
Sorry. Hello?
எங்களோட ப்ரொஃபஷன்ஸ் வேற வேற. ஆனா எங்க எல்லாருக்கும் ஒரு ஒத்துமை இருக்கு. நாங்க எல்லாரும் ஒன்னா உருவானோம். எங்களுக்குள்ள ஒரு அழகான நட்பும் சமுதாயத்துல ஒரு உயர்ந்த அங்கீகாரமும் அமைச்சு கொடுத்தது எங்க எம்ஜிஆர் யூனிவர்சிட்டி. Our university united us.
Dr.M.G.R Educational and Research Institute, University, Maduravoyal.
Fine. I'll quickly get through the session. It's 1 hour session, starting with welcome address, followed by introduction to the speaker, expertise the speaker, and vote of thanks. I request all the attendees to stay till the end of the session. Feedback link will be given in the chat box at the end of the session. Faculties have the most important role to shape the student's career. An institution having the best faculties who are skilled in latest technology will be in the top charts of upcoming years. We proudly say we are one among them. Today's session will be extremely unique. We, Computer Application Department, witness a lot of innovative technologies arising every day like IOT, robotics, etc. Today, in this session, we are going to see something new about innovative technology, tool for simulation of IoT and fog computing. It's great to be a teacher, but it's greater to say a sincere teacher. I now hand over the session to our enthusiastic person, Dr. M.S. Josephine, our additional HOD, to give welcome address.
An ignited mind is the most powerful weapon on the earth, above the earth, and under the earth. And this is got through the awareness education, like faculty development programs and national level conference. Very good morning to everyone present here. It is a great honor or privilege to present the welcome address on behalf of the Computer Application Department, Dr.M.G.R Educational Institute, Chennai. I express my special welcome and thanks to our beloved President, who has kindly consented to conducting this faculty development program and his continuous support to all our efforts. I would like to welcome and thank the organizers for arranging such a useful FDP value addition on emerging information technology. It gives me immense pleasure to welcome the resource person, Dr. S.Thirumurugan, Head of Computer Network Section, Department of Information Technology, College of Applied Science, SOFA, Sultanate of Oman, to deliver the talk on tool of simulation of IoT and FOG computing. We are happy to have the opportunity to hear your valuable talk. We welcome you, sir. Last but not least, I wholeheartedly welcome the faculty members of various institutions for spending your valuable time to attend this FDP. For without you, the program could not have been possible. Once again, I welcome you one and all. Thank you.
Thank you, ma'am. I now request our dynamic person, Dr. Radha Ramohan, to introduce the speaker.
Good morning. Am I audible?
Yes, sir.
Yes. Very good morning to all. Dr. Thirumurugan is working as Head of Computer Network Section, Department of Information Technology, College of Applied Sciences, Sohar, Sultanate of Oman, where he has been since 2008. And before he was working in CAS, Sultanate of Oman, he was in College of Technology, Ministry of Manpower from 2004 to 2008. And he has received a BSc from Sacred College, University of Madras in 1995 and MSc from the CET campus, Anna University in 1998. He received his PhD Computer Science from Anna University in 2004. His teaching and research experience stretches for more than 21 years in prestigious higher educational institutions in India and Oman. He received Excellent Award for Outstanding Research Presentation in IJAS conferences, USA, Instructor Excellence Award from Cisco Academy, 2 Best Paper Award in the International Conference from IIM Kharagpur, India, and then in National Symposium, Oman. His research interests are network reliability engineering and IoT security. He received 2 international research grants and completed successfully. He published 50 research papers in the leading international journals and given 7 seminars at a number of important international conferences and institutions. He organized the national and international conferences several times in Oman. Also edited 4 proceedings in the national conference. Also, he has chaired and gave keynote address in the various international conferences in UK, France, South Korea, Brunei, Vietnam, India, and Oman. He is one of the leading reviewers of Elsevier, Springer, IEEE, and other Scopus Index Journal. Also, he visited Switzerland, Italy, Malaysia, Bangkok, Dubai, and Abu Dhabi for educational exchange program. He has guided 1 PhD, 9 MS, and 9 BS students. He is Cisco certified IoT and big data professional trainer. Last but not least, I would like to express my intimacy towards Dr. Thirumurugan. We have been working in Oman together for really about 12 years. We are closely associated in academic and research for the past 12 years. It's a great privilege for me to be with him, to work with him, and got progress with him. Thank you very much. I welcome once again Dr. Thirumurugan to he's going to give a very valuable session today for all the audiences here. Thank you very much, Murugan. Welcome. You can go ahead. Thank you.
Thank you, sir.
Thank you.
Pretty going and happy greetings. Dr. Thirumurugan, sir, you can take up the session.
Okay, thank you. Thank you very much. Please give the permission to share my screen.
Okay, sir.
It's not enabled.
Not in.
It's visible. Yeah, my screen is shared. It's visible now.
Yes, sir,
Yes.
it is visible. Yes, sir, it is visible.
Okay, thank you.
Yes.
Good morning, dear colleagues and my dear colleagues. This is Dr. Thirumurugan from College of Applied Science, Sohar. Today, I am going to deliver about the tools for simulation of IoT and fog computing. Actually, before starting this topic, let me start with the introduction. You know that IoT, everyone knows it's become viral, and everyone knows that what is IoT. IoT is nothing but the Internet of Things. It's mainly to bring every object online. What are objects? It may be a camera, it may be a wearable, or it may be any sensor or any home appliance as well as vehicles. Okay, once if you make this object online, what happens? Each object may generate the data and massive volume of data that overwhelm the storage systems and data analytics application. Okay, therefore, what is the advantage of making this object online, it's obviously it makes our life more easy and convenient one. There is no doubt at all. Okay. Now, we are going to talk about mainly what are the tools we can use to make the simulation of this IoT, especially, and one area important, the fog computing. Now, I'm going to introduce, there are 4 different tools. The first basic tool, Tinkercad. For example, I am very much interested in IoT. I want to work in IoT. Is it possible? I don't have any equipment. I don't have any prior knowledge also. And right now I cannot buy online because of this pandemic situation. Is it possible to learn? Yes. There is no barrier to learn. There is no struggle to learn. If you must ready to learn. That is the first basic tool is called Tinkercad. It's free to set up, and you can not only use for IoT simulation, you can use for 3D design and even for coding and as well as electronics. The website is given. It is called www.tinkercad.com. Only you need the account. It's very simple. Just sign in your account. Immediately it is ready now. Now, see that this is already I signed in. This is my account. See that my name is here. Okay, it's very simple tool. Please note down, we no need any equipment here to do the simulation of IoT. Now see that there are many options here. One is 3D design. You can make the 3D design with the help of this. But here, that one we are not going to do. Today we are going to do only IoT. Therefore, I select the option circuits. Okay. Therefore, once you select the options, it will give some default values. Mainly, we are going to create the new one. Just click the create a new circuit. Okay. Immediately it will take it to the new circuit design. It's a little delay. Okay. Now see that that page is loaded. Now it's ready. Now I am going to make one simple IoT application. That means blinking the light. This is a very basic application. That one today we are going to do. What to do? We need one microcontroller. What is the name of the microcontroller? Arduino. Okay, we'll take this microcontroller Arduino. See that just here if you type Arduino, you can see that there are a different version of Arduino available. Here we took Arduino R3. See that I took one Arduino. See that very simple simulation. Now automatically it is given the name Arduino 3 R3. Okay. For blinking the light, what you need? Obviously, you need the LED lights. Okay. For example, next LED already it's coming here. See, or you can type here LED. Also, it will display. It will display different LEDs. See, there are 2 LED and 3 is there. Okay, I'll take this LED. I'll keep it here. Okay, I'll move here. Now LED is ready. See, LED, there are 2 pins. One is for ground, another one is for line. Okay, that is a small one is for ground and a long one is called line. Okay, what we need? Obviously, we need the next component to blink the light. We need resistor. Already is there. Okay, just take this resistor and keep it here. Okay, now what is the objective of our simple IoT application? We want to blink the light. This very simple one we can use. Okay, therefore we connect. How to connect? Just click here. See that once if you click, the line will come. Where to join? We need the ground. See that GND, ground. Actually, you know that this is Arduino device. This is having the ground on all the lines available. And what is Arduino? It is a microcontroller. With the help of this, you can control the device. Okay, control the sensors and everything. Now the second one, we must connect this second part, anode part, to connect to the our resistor, and from here it is connect to the line number 13. See, whenever you connect, immediately code is writing. You can see the code. See that the code is automatically written here. You are not going to write any code. Only you are connecting. Immediately see that the build LED high. The code is ready now. Okay, just code. Now only thing we must adjust this the value of the resistor. For example, I am going to change it to the ohms and I'll make it to 220 ohms. Okay, now our simulation is ready. How to check the simulation? Just click this start simulation. See that? See that light is blinking. You can see that here. Therefore, this is very simple application of IoT. We'll start with simple application. How we start? We use the Tinkercad.com. We need only the one account in this website. That's all. Immediately, you can make plenty of IoT application. Usually, you can make simulate. Okay, see, once if you start stop simulation, it is stopped. And what about the code? Just click the code. You can see the code. You can change the code and you can do all the wonders. Therefore, the first tool we got clearly. It is very simple tool to how to make simulation of IoT, especially the devices of Arduino. Okay. Now I'm going to close this one. We'll move to the next one. Okay, now it's very clear. It's a Tinkercad is a free one. You can make the 3D design, electronics, and coding. But what I selected, it is electronics, especially IoT. This is the front view of that website, and already I shown simple demo. Okay, now we'll move to the second tool for IoT, that is called Cisco Packet Tracer. You know that Cisco Packet Tracer, it's a famous tool. It is available in the netacadcard.com or cisco.com. What is this one? Is you can get the great experience with this powerful network simulation tool. Okay, it's a network simulation tool. The same tool we can use for our IoT. Okay. For this one, what we are going to do, we'll move to the next little higher steps. What we are going to do, we are going to use same microcontroller, but one side we have, this is called what? Sensors. Okay, that is we have switch, toggle button, potentiometer, and the flex sensor. These are the sensors available. In the right hand side, we have actuators. According to the action of this sensor, this actuator works. For example, once I put switch, the light is on. Once I press this toggle button, the LED light is on. Okay, once I increase, see that. First one is switch on off. Here push. Third one is I am going to rotate. That means I am going to increase the value in the potentiometer. Immediately this siren will on. And finally, once I make this flex sensor, if I make like flexible, then immediately this motor will start. Okay. For this, I am going to use the tool called Packet Tracer. This is a Packet Tracer. This is the tool. Already, if you are familiar, you can go through that one. Already I loaded. How you can load this device? For example, very simple. Just if you click this end devices, and you can type, say for example, component. Here it is available, single board computer. Okay. Here another one, microcontroller unit. Okay. And for example, if you want to add LED, IoT device, if you want to add the flex sensor, all it is available. See that here the toolbox is available. From here, you can drag and drop. Like that, you can connect this device. Okay, because this one, no need. See, if you click this one, you can easily display what is this one. This is flex sensor. This sensor detect the angle. Okay, for example, if you click this one, what is this one? This is the single board computer, and this is called Raspberry Pi, and this is Arduino. See, this is Arduino. Therefore, now we don't need this one. I'm going to close all this one. Like that, I create this topology. Okay, and already I write the code to save the time. What I did, just I create this topology with sensors and actuators, and already connected. Actually, this microcontroller unit connected with the 4 sensors and 4 actuators. And also code is written in this each place. For example, if you click this one, okay, if you click this one, you can see that what you can see here, what is the specification, what are the specific physical devices, and configure and attributes. Okay, these are the different specification of this actuators. And right side, left side, we have the sensors. Now, where we can write the code, obviously, it is in the microcontroller. Just double click or single click, you can see the program. See, the programming is already I wrote. Actually, this programming, most of the program, it is available online for testing anything. See, it is written in Python. See, there is main.py. P is the Python program. It will display here. See all the code. What is the code? Obviously, for example, it is a very small one. Okay, I'll take this, highlight this one. For example, if switch value is high, very simple code, no, not a complicated code. If switch value is high, immediately switch on the light. See, custom write. See, what is the condition? Check the sensor. If sensor value is high, immediately we'll make our actuator make it light on. This is very simple. How it is working? See, I'm going to use my Alt button and click. See that? Now see that you can see the light is on. See the, because why it is on? Here I am clicking. This signal is passed to the microcontroller, and microcontroller activate this actuator. That means once the fire is triggered in the sensor, immediately the sensor send the data to the microcontroller. Microcontroller immediately switch on the light. Next one, for example, the next sensor is the toggle button. Just I click. See that this signal is sent to the microcontroller. From that program, immediately LED light is on. Okay, therefore you can say that this is very simple one. Why we need IoT? For example, next one is a potentiometer. Now see that once I'm going to increase the angle using Alt button. Please note down, if you not use Alt button, this will not work. Okay, now see that. See, now I'm going to increase. See that immediately the siren is signal is on. You can see, have a look. And this is a third actuator. This is a signal. Now the last one, see the motor is not now normal now. The program already written there. I shown you it is available in the microcontroller unit. See, now I'm going to see if you without using Alt key, it will move like this. But if you press with Alt key, it will actually see that. Now I'm going to change the angle. Once I change the angle, see that according to the angle, the speed of the motor is working. Now see that. Once I commit here, it will stop. Now once I rotate, it is working. Now if it is full, it is going very fast. Now if you make it straight, the angle is straight. Now fan is stopped, motor is stopped. Like that. See that? Okay. Now where is the program? Here is a program. Very simple program. What is the last one? See, if flex sensor is greater than 0, analog write, not custom write, it is not on off because we are going to rotate. Stop 0 or negative, whatever it is, it will stop. This is very simple application of IoT, how to make the simulation. Okay, now we'll move to next level, little more higher standard. Okay, little more higher standard. We'll go that one. What is that one? We'll how to make simulation of city. Okay, this is a simple example, smart city. What is this smart city? We have the smart grid, and we have the smart home, and the smart parking, smart traffic. The smart home, smart parking directly connected to the cellular tower, as well as your city office also connected to the cellular tower. Okay, your cellular tower is connected to the ISP cloud, and ISP cloud connected to your city office. What is city office means? Nothing but the control room. That is the police station, or who is administrating this city. That is called city office. Now we have the smart grid, and this is smart home, smart parking, and the smart traffic. Okay, what is simulation we are going to make? For example, if you are going to plan to develop smart city, how to make a virtual simulation in the smart city? Now, See, what is the first one? First one, we are going to explore. We are going to explore the smart city, and we are going to what is ISP cloud and what is city office, what is cell tower, what is smart home, and what is smart parking. Okay, these are the things we are going to go one by one. Now, what to do? Just to open that one. Already it's loaded in the packet tracer. Now see that already loaded. How to create this topology? Very simple. Just put one image background. After that, you can add. See, if you go here, for example, I want to add one cellular tower. Just type. You can see the cellular tower. See, you can add it here. Next, how I can make the traffic. For example, here you can add it here, and inside you can add it. Like that simple way you can add, because of I cannot show the demo for everything. That's why I created already, and I am showing the examples. Now, first step we are going to explore. What is ISP cloud? Just double click. You can see that what is inside. There is one DNS HTTP server and one central office server, and here there is one ISP main router is there, and here we have the cloud, and here the cloud is connected to the coaxial splitter, and this coaxial splitter connected to this one. Okay, go back. Now, what is the city office? You can see that it shows the typical setup of the city office. Now, see that the simple diagram, and it shows this is the city office with in office number 4 there is one PC4 is there. In reception there is one PC. In the waiting room there is a fancy fan also connected to the access point, and here whether the visitor comes with smartphone, that phone also connected to the access point, and the windows also connected. And here the traffic control, see, all it is connected locally. Here the traffic control connected out, and you can see that the smartphone connected to the access point of the city office as well as connected where. That is the question here. And here we have one router in the city office. This router is having one IOT server and one laptop, and remaining office it's available here. See, this is a traffic control. This is a control room for traffic, and everything available. All the, even see that the city office door also, it is connected to the our access point. You can control everything. Okay, now go back. This is the city office. Now we'll go to the smartphone. Okay, there is one smart home available in the city. See that in the smartphone, all see that we have the garage door, car, and solar panel, and here home gateway, and here we have the coaxial splitter. All the devices at the home also connected to the home gateway, and some devices connected directly to where. See, there are two devices. One is a smartphone connected to the home as well as outside also. Okay, and another one, the tablet also connected. See that, just I drag, the tablet is connected to the home gateway as well as connected outside also. Where is outside, that we'll see. Okay, now we'll back here. Now we explore ISP cloud, city offices, cell tower not explored, smartphone. Still it is pending, smart parking and the cell tower. Okay, now I'm going to explore the smart parking and cell tower. Where is smart parking? So smart parking. See that there are 4 cars on the road, and if you come that nearby the road, there are 5 parking spaces available. If you come down, this 5 parking space sensor connected to there is one parking server, and here we have one camera, and here we have the access point, and here the parking switch, and there is one parking router also available. Okay, this is the setup available in the parking smart parking. And if you click the smart traffic, see that here we have the traffic light, and the ambulance. See that ambulance is connected to the traffic access point, because once ambulance comes, according to that, this our smart city makes a space for the ambulance and make it right. And here we have the traffic light also available here. Okay, now we almost explored all the things. Now what we are going to do now, and we are going to experience one simple simulation: smart parking. See, smart parking cluster allows city official and citizens to benefit of IoT implementation. How it is going to work? First step, open the city laptop and go to the browser and enter this address. This address is nothing but the city office server. Okay, now I'm go there where I'll go to the city office. I'll go to the city IT laptop. I'll open. Where I must go, I'll go to the browser. Okay, I'm going to enter the IP address of city IoT server. Where is city IoT server? It's nearby only, but we can visualize in our laptop. 195.0.0.2. Okay, once if we enter, it will ask you must have the proper user ID and password. For example, here the user ID is park, because I am going to simulate the park. Now see, just click, immediately you can see that what are the IoT sensors available in the park. Parking space 1, parking street light 2, parking street light 1, parking street camera, parking space 2, 3, 4, 5. You can see that. What is actually in the parking space 1, there is one metal detector is available. Currently the sensor is 0. Why? Why it is 0? If you go back to the parking sensor, okay, if you go back to the parking sensor, currently there is no car parked in the parking space. That's the reason here it is showing our parking space metal detection says that it is 0. Okay, it is 0. Now what I'm going to do, I'm going to take the red car. I'm going to park in the parking space 1. Now you can see now, immediately see that the laptop in the city office detect that the car is parked in the parking sensor. That's why the value is changed to 20. Okay, the value is changed to 20. Now we observe that clearly. Using the city laptop, we can easily sense what is happening in the smart parking place. Now, only in the city laptop, why not locally in the smartphone? For example, the customers or the people, those who are visiting nearby the place, now they have the smartphone. For example, once they click the smartphone, now they can use the app or web browser. Now I'm going to use web browser. Okay, 10.10.1. It is connected to the parking manager. See, where is the parking server? It is this your mobile connected to the tower as well as connected to the access point. Once I enter this one, what it is showing clearly, the parking space of 1, it is taken, it is showing in the red. It is showing in the red. Now what I'm going to do, I'll take the green car and I'm going to park it in the parking space 3. Now you can check here, this is a lengthy code. Because of simulation, I made everything previously as an example, okay, available, and I am showing the demo, that's why. Now see that immediately parking slot 3 is taken and it is occupied. Okay, how it is possible? Because the sensor send the data to the city office. Okay, the city office detect. Now see that here space 1. What about space 2? Space 2 is 0. Why? Because there is no car parked. Space 3. What about here? The car is parked. That's why metal detector is 20. Immediately it is updated in the here what? Updated locally in your parking sensor as well as updated in the city office laptop. Therefore, from the city office laptop, you can easily understand what is going here. Okay. Now, if you check the mobile phone locally here, now how many slot is free? Only three slot is free. That is available. This you can use like web browser or app, anything here you can use. Currently, for the demo purpose, we use the web browser. Now, see that what are the slot free? That is also you can easily see in your mobile. What park slot is one is taken, 2, 3, 2, 4 and 5 only available. For example, if the car is moved from that slot, you can, it is immediately updated in your in your mobile phone, as well as it is updated in the city laptop also. See that if you check here, now the value is 0. Okay. Now this is an example how you can make the simulate your IoT device online. For example, here we put the simple picture. One, we put it in the we create the cloud inside. We'll add it here, and we added the tower and we connected. See, everything it is connected, and actually I use IPv4. Now see that it is here. Here, what is that one? We use 3G, 4G server. That means it's a mobile connection. That's why, see, this tower is connected to the smart home. Now, in the smart home, if you click here, you can explore here. Is it possible to check from here itself? Okay, but this one, it is connected to the tower as well as is connected to the home gateway. Okay, if you enter the home gateway IP address, you can easily visualize all the details available here. Okay, this is a home gateway. See what is the internet address is given, as well as the LAN address is also given. Therefore, this also you can see that, but mobile phone is connected with your home gateway as well as to the cellular tower. Therefore, this is with the connected home gateway. Okay, and the cellular tower connected to the cellular device. This is a smartphone. The tablet also connected to Wi-Fi with the smart your home gateway with Wi-Fi. The cellular tower. See, therefore, there are two devices connected: home gateway as well as cellular tower. If you go back, similarly, you can guess. See, in the smart parking also, if you click, there are two devices connected to locally the access point. See, this is a wireless router. See, wireless router, it is connected to the cellular tower as well as connected to this our city office. Okay, your smartphone connected to the cellular tower as well as connected to the access point. Okay, this is the thing. Now, if you go back again, if you check with your traffic, here also same like that. But here in the traffic, your emergency van, your light, and the traffic light, one in the left, one in the opposite, it is connected to the locally only, not connected to the cellular tower. Okay, that is a point. Therefore, from here, what we understand here, you can create any IoT project. That project, you can create the the design using the packet tracer. Okay, not only simple one. This is the entire city you can plan. You can write the program. For example, you want to check the program where it is available. For example, the first one, the parking sensor. If you check here, the programming section, you can see all the program, whatever receiving signal and whatever actions, all it is written in the clear program. How it is connected to the city office server, IoT server, and how it is receive the data from the server, receive the data from the sensors, and how the value changes. Everything we wrote the code in this one. Okay, therefore, this whatever the actions I am showing here, it is working based on how the program codes run. Okay, how the program codes run. say for example, if I move that, according to that, the programming is running immediately. See that the parking light also it's on and off depend on the situation. See that here, if any vehicle is moving, that is also that is also captured in the web camera that is uh, available in the server. All the details you can easily catch sit at one place. Okay, now just now we explored the smart city simulation, how it is possible in the packet tracer. Now I'll close the packet tracer because we saw two examples. First example is simple example, that means with microcontroller how to collect the data from the sensor and how to make the actuators work. Okay, and the second one, it is little more high level. That means we create the smartphone, smart parking, smart traffic, all this smart parking and smart traffic connected to the city office, smart parking connected to the cellular tower as well as city office, and the smartphone connected to the cellular tower and connected to the ISP cloud, that is internet. Okay. Now this is the one we seen just now. Now we'll move to the third tool. It is really helpful for the research purpose. Mainly, for example, if you want to simulate the especially for the edge computing, fog computing, and IoT. And very interesting one, the first Tinkercad, it is open source free. It's available online. The second one is a packet tracer. You must download from the Cisco NetAcad and you need the account. Without account, you cannot work this packet tracer. You need the Cisco account required. Account means normal user ID and password required. Okay, and this iFog is an open source tool. It is enable. What is this one? Mainly, it is enable the modeling and simulation of fog computing to evaluate main purposes to resource management and scheduling policies. It's an interesting one. Actually, there is one researcher in Australian university. He developed this iFog simulator and he proposed. Why he developed this iFog sim? That is very simple. See, we know that we have IoT. It is IoT means Internet of Things, that is connecting the objects, and this once objects are connected, that is going to generate the massive data. And obviously, how you can connect using the cloud computing, we are going to storage and processing requirement. However, for example, such as applications such as health monitoring and emergency response, it requires low latency. If you use cloud computing, it may expect some delay. For example, we have the ambulance or we have some emergency, we cannot depend on cloud. We must take immediate action taken care in the locally. How it is? That is why, because of this seriousness of impactness, we need the proper application. We need move to the fog. That means fog means it is you take the real-time analytics. Clouds, maybe you can expect the cloud computing, you may expect some little delay, but in the fog computing, you cannot expect any delay. Immediately, it will take the actions and it will solve the problem. The main problem, okay, we have the cloud computing provide all the services and offer services infrastructure level to storage and processing. And we have the fog computing and it is having the full potential of real-time analytics and several challenges it is addressed here. What is the main critical problem in the fog computing? How you are going to manage your resources. Okay, main problem is how you are designing the resource management technique to model this analytic applications. That is a major problem. That's why this researchers, Dr. Rajesh, and they offered the iFog sim, how to manage. That is a one simple one. What you need, how to set up the iFog, the simulation tool, how to run, very simple one. First thing, you must go to this website, okay, that I'll show you. See, this website, and first you need to download. Okay, just click this one, download zip, and stored locally, and you need, obviously you need Eclipse. Okay, you need Eclipse tool to run this one. Okay, I stored here where I stored. Okay, I stored here. There is one here I stored, and after that I extracted here and I stored it clearly local. Okay, therefore the first step for this iFogSim, you need the code that is from the GitHub. Now I'm going to open the Eclipse. I open the Eclipse. One minute, yes. It's loading Eclipse. All the code it is written here. Only what you allot what are the resources you are going to use. According to that, it will easily simulate and estimate the resource management required for that particular IoT simulation. Is IoT and fog computing simulations. You can see now this Eclipse is running. Okay, in the meantime, okay. Yes, now it's loaded here. Now how I am going to run this iFogSim simulator. Okay, just click File, New. I selected the new Java project. Okay, I am going to give the project name is called FogSim Master. Okay, next use the location. Just for example, where I stored on the desktop, name called for demo. Inside I stored, selected folder. Now click next. Immediately the tool is loaded in your Eclipse. See, it's loading. Okay, you can see that. Just click finish and just expand, and here you can see all the application, and here what are the things you needed here. All the I am going to show an example here. iFog GUI, that is a graphical user simulator. Okay, before that, make it run. Debug as Java application. Okay, just click OK. Before running, yes, successful, done. Your tool is ready now. Now I'm going to run this one example. Run as Java application. Yes, now it's ready. Okay, now I'm going to make simulation. Already I made one topology here for the example. Just I'm going to open the topology. It is I stored in the desktop. Okay, we'll go to the desktop, and I made one demo. Where is the demo? Yes, demo, and I master. Okay, topologies. Now we are game topologies. Okay, this is a top. You can create a topology. There are so many tools available. What is this one? There is there is one proxy server here, domain 1, domain 2, and here the local one. Here there are two sensors connected to this one, and these two sensors are connected, and finally it is connected here. Okay, now I'm going to run this one. Now it's ready. See that once I loaded immediately here in the Eclipse output place, you can see now clearly what are the node and what it is available, what it is added. See, it added 2 edge, and it is having 4 sensor, EEG sensor, and everything. It is available here. Okay. Okay, now I am going to run that program. One minute, please. Runners Java application. Yes. One minute, please. And for this one, we have the fog examples. That is 1 minute, please. Runners. Yes, Java application. Just now I shown you. Demo. Open that fog simulator and topologies, and we are virtual game. Okay, for this one, we are virtual game. We have the code. We have the code, and that code, we are virtual game. Code is available here. It is loaded here, and that one, if you run, immediately it will show the output and how much resources required for this fog's IoT simulation. Now here it is shown clearly how many nodes and what are the target things it is available here. Okay. Like that, you can run the research purpose of fog and IoT simulation. Just now I'll close now. Yeah, here what we understand here, we have the GUI application, the GUI app, and here you can load your topology. And once you load it, and after that you must write the code, and that code is available here. That code you can run. Okay. That code run it here. It is available here, and you can run. Once if you run, obviously you will get the final result here with the applications. Now I'll close this one. And this is not only tool, and one more tool is called, it's an interesting tool, but it is only 15 days free. After that, you must pay the money and you can use. That is a device IoT simulator. It's an interesting one, and most of the researchers, they are using this one. This is an exhaustive IoT simulator for IoT MQTT. What is MQTT? It is a protocol to exchange the data from one object to another object. It is low bandwidth. And this is it's an intelligible simulation tool. It can simulate tens or thousands of MQTT clients in a single box. That is the advantage of this simulator. Okay, therefore, today we discuss 4 different tools, especially for IoT, fog computing, and edge computing. We start with a very simple online tool without any installation, that is called Tinkercad, and after that we move to little advanced one, that is a packet tracer we used. After that, we'll move to the next one, iFog. That means how we can do for the research purpose. Just I show the example only, the demo. The last one, maybe IoT simulator. I didn't show, just I show the information only for you. Thank you very much for listening. I want to thank Dr.M.G.R, the Deemed University, given the opportunity to deliver this lecture. And also I want to thank the Vice Chancellor, Madam, the Dean, the Faculty of Computer Science, the HOD, the Department of Computer Science, and those who are helping to run the show, especially faculty members. I thank you very much. Now, if you have any question, please I'm ready to answer your question. Thank you very much.
Thank you, sir. Enlightenment is growing all the time, which sometimes that happens and complete the human knowledge. Today is again the best example for that good. Thank you for the unique session, sir. It's been a new experience learning many things in the session. Now, it's a questionnaire session. So I just have only one question. Can we have options for bots and drones as they are more prevalent in current projects?
Madam, ma'am, I didn't get you. Please, once again.
Can we have
Hello?
options for bots? Yeah, sir. Can you hear me?
Yes, ma'am, we have options that is available with a simple packet tracer or normal one. If you want to find the allocation resource like that, you can iFox SIM also you can use.
Okay.
Yes, ma'am.
So the attendees, they have posted one more question. Is this tool for using only design purpose, or we can able to do a data analytics also?
100% we can use the data analytics. Actually, that is a separate section is available. I didn't show that one. For example, if you go to the packet tracer, you can open that server. Actually, in the server, store the data. There we can do all the analytics. It's possible. 100% it is possible. You can do the data. That is separate section. We can do a separate seminar for that data analytics.
So
using
soon
the
we can
packet
join
tracer.
us again for the other session also.
Yes,
So,
yes, thank you.
there's one more question also. Any limitations in Tinkercad and NetaCAD?
Actually, in the Tinkercad main limitation is it will support only for Arduino. But if you want to do more simulation, like suppose if you want to run in Python, it's not possible. It is a built-in program only available. But in the packet limitation, I can say maybe very, very less, because it is mainly promote only Cisco product. That is only limitation. But it will support exclusive all the IoT devices and what is a network device. Everything is possible in the packet tracer. But in the iFox sim, it is mainly for resource management, that simulator.
Oh, okay. Okay, sir. So one more question. What is your advice for our PG students who is going to do project on IoT or for computing?
Yeah, it's a very nice question. Very simple. That is why usually I'll tell my students also, I'm going to do IoT project. I'm going to buy Arduino. I'm going to buy this sensor, that sensor. Just ignore all the things. First, list out what is your requirement and plan the design using any of the tool. Once the design is ready, designing purpose, the Tinkercad is best one for design purpose. You asked last question, I'm telling you. Tinkercad mainly we can use for design purpose, and programming and purpose you can use the packet tracer. For resource management, we can use for iFox sim. Okay, once you made a design and write the programming code, everything using the packet tracer, make sure that your whatever your visualize IoT project, it works in the packet tracer. Then you can go for the real device. Then you can minimize your cost. Number two, you can remove the all bottleneck of the problem in the IoT project. That is the main thing here in the packet tracer. Another point, once if you write program, virtually you are confident. If you move to the real device, some flaws available in the packet tracer simulation. Once if you move to the device, you have full confidence to execute any smart city or any related to the smart projects.
Okay. Thank you, sir. It was wonderful session. Now I request Dr. Radha Ram Mohan to join us to thank the speaker on behalf of our university.
Very excellent session. No words to express, because no one could explain in a very short span of time, matter of 45 to 50 minutes. You are able to cover nearly about 4 tools, starting from Tinkercad, then NetaCAD, then iFoxim, then DC5 simulator. It's a very fantastic, Dr. Thirumurugan. I am really amazed to see so many tools have been explained in a very short duration with a very crispy explanation and excellent example, simple example, where any newcomer or new person who is want to practice the tools can understand. I really thank you very much for this. We are all very privileged to listen to such a lecture. I thank you very, very, very much. Thank you.
Thank you very much.
Thank you, sir. Ms. Nishanti, Assistant Professor, connected with us to deliver vote of thanks.
Thank you, Sarika. Good afternoon, all. Myself, Nishanti, Assistant Professor, MCA of Dr.M.G.R. Educational and Research Institute, deem it a great honor to propose the vote of thanks on this memorable occasion. First and foremost, I thank our Honorable Chairman, President, respected Vice Chancellor, Dean, HOD, Additional HOD, our colleagues and all participants. On behalf of our department and organizers of the FDP program, my heartfelt thanks to Dr.S.THIRUMURUGAN, our special guest and speaker of this session. Also very grateful for accepting our invitation despite his busy schedule, has found to grace this occasion. Our deep sense of appreciation of his insightful lecture on tool for simulation of IoT and fog computing was full of wisdom and knowledge. He also shared with the faculties the tips to make optimal use of mind power and inner potential. We teachers were enlightened by your excellent speech, sir. We have been fortunate enough to attend this lecture and will be able to extract best results out of students by applying these tips in our teaching. Last but not the least, I thank each and every one of you for your cooperation in making this session a resounding success. Thank you.
Thank you, Nishanti. Thank you once again, attendees, for your valuable time. Hope you have made the best time out of the session. Stay tuned for the next session tomorrow, same time with different interesting positive call. Take care. Bye for now.